Hello, welcome to Professional Software, a weekly YouTube channel focused on helping you level up your software skills. So this week we'll be talking about explicitly defined domains. So let's get started. A domain is the subject of a piece of software. So in front of us is an example of a auto sales domain. We have four entities: a customer, vehicle, inventory, salesperson. Each one of these entities has a relationship to another entity. And what's cool about domains is that they exist independent of software. So these concepts exist as sort of business functions or business practices or business entities. And then our goal as professional software developers is to encode these domains in software, these entities in software. So we target it with our software, and then we model that business process using these entities. So this means that software always has a domain. As long as software does anything productive for a business, it has a domain. And then it becomes, is that domain implicitly modeled or explicitly modeled? And so this is an example of an implicitly modeled domain. So implicitly modeled domains aren't standalone concepts. There's no place for you to point, say, that's a user, that's an account. There it is. And so implicitly domains usually define these domain entities as a side effect of implementation or as functions. So in this example, we have three methods. We have an enroll user method, a remove user method, and a notify user method. And so user is a core domain entity in this software program. And you see here within these method calls, important user attributes are being defined. So an ID is essential to a user, a first name is, and a last name. And so each one of these functions shares the definition of what a user ID is. And this is a visual representation of this concept. So we have the same three functions, and what we have here is the domain entity user is implicitly defined inside of these functions. So it exists within the function definitions. And so this creates unprofessional software for three major reasons. So extensibility. It's very hard to extend implicit domain definitions. So in the future, as the concept of user changes for the company, say that the company wants to add a surname property. And what happens is adding that surname cascades to every single implicit definition. So there's just not one place where we can update a surname. We have to update each one of these individual functions to accept another surname parameter and to provide it to the functions here that they delegate to. And so what happens is that adding a simple field like a surname isn't constant time, it's linear time with respect to the number of implicit definitions. And what usually happens with that is a product owner or a business person says, hey, let's add surname. We want to start capturing surname for a user. Engineers, how long will that take you to add? And the engineers say, the first step is, well, we'll have to see, because there's implicit user definitions spread all throughout the software. And so they check, they audit all the locations of the software, which may be tens or even hundreds in huge projects. And they say, oh, adding this surname field may take 2 weeks. And the business people are like, well, how come adding one simple field takes 2 weeks? And that's because the user entity is implicitly defined in multiple different places. So the same problem exists for maintainability. When bugs happen, the changes cascade through all the definitions. So you see here, ID is supposed to be a unique identifier, but it's using first name and last name. So this is a bug. And so when we determine that's a bug, we'll have to go through and fix it. The engineers will have to fix it. And the exact same problem exists with extensibility. They'll have to go and fix every single implicit domain definition. And the final problem with implicit definitions and why it creates not unprofessional software is through verification. And verification in implicit definitions happen as a side effect of the methods that contain the definition. And to make that more concrete, this is an example of a unit test for Enroll user. And why this is misleading is because we actually just want to test the user ID generation. But the identifying a user, which is a core attribute of the user entity in the domain, takes place within this function. So we have to actually invoke enroll user to test the ID generation. And that's a code smell for an implicitly defined domain. So we have a test enroll user here. We actually have to enroll the user. And then as a side effect here, we assert that the ID is generated correctly. And we can run this. And this passes. But the whole verification process in the unit test is quite misleading because we're testing the ID generation, but we have to do that through the enroll user. So now that we've covered implicit domain definitions, what does an explicit domain definition look like? And so I've opened up here an example of an explicit domain definition. And you see here we have a user class and we have a single create user method. The user class defines the attributes of the user, the first name, last name, and ID. And the create user method is the single entry point into creating a user. And one important thing to note here is this is not object-oriented programming. These are not subclasses, these are not type hierarchies, these are not inheritance or polymorphism or anything. It's just an explicit definition, and in Python, a group of attributes with actions associated with them can be implemented in terms of a class, but this may be a struct in JavaScript, this may be an object in JavaScript or a struct in Go or a class in Java, and in Python it's a class. And so what happens here is we create a single location in the software where we define the domain entity user. There is only one place where this exists. And this is an example of how this shifts from the implicit definition. We bring the definition of a user outside of the function body to exist on its own. And so instead of being nested inside of each one of these functions, each one of these functions accepts a user. We inject a user into each one of these functions as a parameter. And it creates a completely different relationship. Each one of these methods depends on a user, but a user exists outside of any one of the methods. And so extending this becomes trivial. So say the business people come and ask for a surname. Well, there's a single location. It becomes a constant time operation. We can add a surname. Easy. There we go. It's a constant time operation. We add it to the user definition. We add it to the create user method. It's a constant time operation. And so that's extensibility. Extending it becomes constant time. Maintainability also becomes constant time. When we recognize the bug with this ID generation, there's a single location that we need to update. User ID, we can change this to be a UUID, to include the surname, whatever logic generates a completely unique ID. And that occurs in a single location because it exists outside of any implicit definitions. So that also becomes a constant time operation. And finally, verifiability. This is an example of testing the user ID, a unit test that tests the user ID. And what we have here is an extremely focused test. There are no side effects, there's no patching. We test the user ID, we create a user, we access its ID, and we assert that the ID was generated correctly, so that when we do have to fix this bug, it's quite trivial to verify. And this all happens, the entity that comprises the domain, the user, is completely independent of how it's used. It's a standalone concept, and it's quite easy to extend, maintain, and verify. And so this was a brief introduction and post about explicitly defined domains, and I hope you enjoyed it, and I'm looking forward to the next video next week. Thank you so much.